my video on topic number 1, which is intermediate value theorem, mean value theorem, and hyperbolic functions. So I'm just getting started with the hyperbolic functions. So let's just start off with the definitions of those. We got sine hx. So for hyperbolic functions, they have the x or the h added before the x. So sine hx equals cosine hx. Cosine hx equals just sine hx. Tangent hx equals secant squared hx. Cotangent hx equals negative cosecant squared hx. I forgot an h there, oops. Cosecant hx equals negative cosecant hx, cotangent hx. Secant hx equals negative secant hx. Secant hx equals negative secant hx tangent hx. And we have some of the identities here as well. And some of the identities we have are sine h of negative x equals negative sine hx. Cosine h of negative x equals positive cosine hx. And cosine h squared x minus sine h squared x equals 1. And 1 minus tangent h squared x equals secant h squared x. And that is it for the definitions and identities. I'm going to do a couple example problems now. Okay, so an example here is we have f of x equals 3 sine h of 2x. And so we're going to go ahead and take the derivative of this guy here. So first, that 3 is going to be that coefficient, so we're going to leave that guy out. And then we do the derivative of the inside there, so we have cosine h of 2x. And then we have to do the derivative of the inside of the sine there, which will give us times 2. And so our answer should be 6 cosine h2x. Alright, and that's problem number A here. And let's just do another small example here. So we got B, which is going to be f of x equals negative e to the x and multiplied by tangent hx. So let's go ahead and take the derivative of that. And so we got a product rule here, so we take derivative of the first one, which is just going to be that negative e to the x times the second, so times tan hx, and then we're going to have plus derivative of the second, so derivative of tan hx is going to be secant squared hx, and then multiplied by the original one, so multiplied by negative e to the x. So both of these terms have a negative e to the x, so we can actually go ahead and factor that guy out, and then we'll have negative e to the x times tan hx plus secant h squared x. And so those are some simple problems for some hyperbolic functions and the derivatives. And moving on to the intermediate value theorem here. Just a quick definition, we have suppose f is continuous on an interval of a to b, and let n be between the interval there of f of a and f of b, where a does not equal b, then a number c must exist in a and b so that f of c equals n. So just a small example of that, we're going to show there exists at least one root in the equation here using the intermediate value theorem. So we have the equation of 4x cubed minus 6x squared minus 3x minus 2 equals 0. So we are going to let a equal 0 and b equals 2. That is our interval, so let's go ahead and plug in for f of a, and we get negative 2 for f of a, and then for f of b we get 12. So we have determined that by the intermediate value theorem, there exists a C value in the interval 0 to 2, such that f of c equals 0, since f of 0 equals 2, f of 0 equals negative 2, and f of 2 equals 12. So that we have f of a c equals 0 in there. Alright, and moving on to the definition for the mean value theorem here, we have if f is a function that must satisfy these following conditions for this theorem. So condition number 1 is f is continuous on the closed interval of a to b, and 2, that f is differentiable on the open interval a and b. And if we meet those two conditions based off the mean value theorem, then therefore there exists a c in the interval of a to b such that the derivative of the function of c equals f of b minus f of a all over b minus a. And so that's our equation that we're going to be using for the mean value theorem here is the f prime of c equals f of b minus the f of a all over b minus a. And I'm going to go ahead and also do an example of the mean value theorem here as well. And so for our example here for the mean value theorem, we have the function here of f of x equals x cubed minus x. So we're going to go ahead and set a to 0 and set b to 2. And so now we're going to plug those values in into our equation here for the mean value theorem. So we're going to have f prime of c equals f of b minus f of a all over b minus a. So we have 2 cubed minus 2 minus 0 all over 2 minus 0. And that leaves us with 6 over 2, which equals 3. So now what we have to do with that 3 is that 3 is equal to f prime of c. So to find the roots, I believe, what am I saying? To find not the roots, to find the numbers of c that satisfy this equation. So we're looking for the values of c. So to do that, we have to find f prime of x first. And so we have f prime of x equals 3x squared minus 1. And so now we set our f prime of c equal to the f of x here. So we have 3 equals 3x squared minus 1. And then as we go through the math, we bring that 1 over, get 4 equals 3x squared. Divide by 3, we get 4 over 3 equals x squared. And then we take the square root of both of those sides, which leaves us with x equals plus or minus square root of 4 divided by 3, which leaves us with our simplified answers of x equals plus or minus 2 over rad 3. But again, we have to look at our domain we have declared here, which is going to be between 0 and 2. So we don't have any negative numbers. So our c that satisfies the answer here is just going to be x equals positive 2 over rad 3. And that is it for my explanations and simple examples. And I will be providing some sample problems for each of these guys. Hope this helped. Thanks.